F1, we're going to do the incline with friction. So incline and friction. We did the incline before without friction. So we're going to look at here an incline. Which is a fixed incline, and a mass here that's going down, moving down with friction, and theta. I like to draw my force diagrams at a slant. To match the slant there. And remember here, theta, and when you go straight down with your force due to gravity, this angle here is theta also, since they're both complementary to that angle. You know, this is a right triangle, and then right triangle there. So this is N, and the friction, kinetic friction force is going up the incline. So there we have the sketch. Remember our 4 steps. Then we have here the force diagram. And then the 3rd step, equations, Newton's laws. So here, we're going to pick going down as positive, like that. So going down the incline, we have mg sine of the angle. All right, we have seen that before. If you have the mg going straight down, you can think of that as having a component along this normal and then perpendicular. So that's the slant, that one there. So since that's your angle, this is the mg sine of theta, and this one here is mg cosine theta. So mg sine of theta down the incline minus the kinetic friction force is equal to ma. Then for the other direction, where it's nice to let people know what you're doing for plus, in that direction it's going to be along the normals plus, so n minus mg cosine theta. There's no acceleration, it's not levitating in that direction or going into the table. And then here, the auxiliary equation I like to think of, we add another equation, the friction equation here, mu k times n. And then I like to work from the bottom up. I like to work with these 2 equations and get fk is mu k. This is mg cosine theta. When you solve this one, the n is mg cosine theta, and you put it in there. Then I like to go to the top equation, see, and put that in there. And when I do that, I'm going to get mg sine of theta minus mu k mg cosine of theta is ma. Now in these problems, you want to find the acceleration. So that's assumed that that's what we're looking for. We could actually state that first as a question. What is the acceleration? So you notice that the mass here drops out. So it doesn't matter what the mass is, you're going to get the same acceleration. So that's going to give us here, the g is going to factor out. So you're going to get here sine of theta minus mu k cosine of theta times g. That is the answer. And let's let's like check our answer here. Remember, reflection is always important when we're doing problems to see if our answer is reasonable. So what we're going to consider first to check our answer is what happens if it's 90 degrees. If this is 90 degrees, then the normal force is going to go to 0, going to be no friction, it's just going to fall straight down. So with 90 degrees, you have then the sine of 90, which is 1, minus mu k, the cosine of 90, which is 0. And that's going to get you 1g, and that's what we expect. Now, another check we can make real quick is if there's no friction. If there's no friction, do we get the answer we got before? Well, we do, because if there's no friction, you get g sine theta. And that's what we got in the other chapter when we did the case of sliding without friction.